So welcome everybody to this tutorial on multidimensional process analysis. My name is Dirk Farland. I've been doing BPM research for, I don't know, 14, 15 years now. Yeah, 14 years it is. 2008 was my first conference. And I've been pondering a lot over these 10 years how to deal with processes that are not just a simple single insurance claim that you handle from start to end, right? So all the problems that are always mentioned in the keynotes, right? So how to deal with them. And it took quite a while, but especially in the last 4 or 5 years, quite a few results have emerged. And it was time to summarize this. So this is what I want to do today in this tutorial. I think I'm going to fill the 2 hours. So, but I'll also involve you. I'll ask you questions. So I'll try to be easy on you. And if I see you dozing off, I'll stop. So I'll start simple, and towards the end is the more advanced things. So let me start simple. We want to study, improve processes in the real world, as Jan just mentioned in the comment to Jan Menling's keynote. So these processes in the real world, we design all kinds of systems, right? BPM systems, information systems, decision support systems, AI systems, whatever it is. It's very rich. They're there to support these processes, but sometimes also the processes support these systems. What matters for us is through these systems, when we can record data and we can analyze this data to obtain models or kind of compare the models that we have with the data. And these models are there to describe the processes, but also to improve them. This is a picture that Wil van der Waals has been creating, I don't know, 15 years ago, and it's still valid. So let's have a look at this process. What is a process? Processes happen in the real world. For example, in logistics, when we let machines move around items. That's not the first kind of process you think of, but they're happening. We have processes where people work in organizations. They're actors, so they do things according to what the company is doing, but also on their own. We mostly use documents to manage the information flow. These documents tell us what to do, and we create these documents to tell other people what to do. We also have all kinds of procedures and rules in place to manage how people do the work in a way that we have the outcomes that we want to have, right? Healthcare is a prime example. You can't just do anything. You need to follow particular guidelines. So all these things are there, and they're complex, and they're brought in by different people, right? It's not just a single person who's doing that. And we have different, stakeholders in that sense, right? Actors work in the organization, managers, customers, people who are affected by it. They all have their own goals. They have their own way of doing things or what's possible. And you have to agree on this in the real world. That's why we have these models. We're creating these models to describe or even prescribe how to work as an actionable means of communication, right? So these models, that's what process management is really good at. They're not just a statistical model that nobody understands. It's a picture you can show to different people and they understand what's supposed to be happening. So this is crucial. The second thing that we need, and that agreeing on goals and actions relies on, is that we have data that is accurate. Not just accurate in a quantitative sense, but also in a qualitative sense. It has to reveal to us the relevant phenomena that are important. So let's compare this picture to what we are doing or have been doing over the last 20 years. We've been developing in the early stages of the BPM community process modeling languages, right? YAWL is, say, the prime example of the academic development that incorporated all kinds of patterns of how to model workflows into simple constructs. They're derived from Petri nets, but they're not exactly Petri nets. But they take this idea that you have local transitions in places because they're perfect fit for processes. And these models, they made it over into industry, into industrial standards like BPMN, that we now can just deploy in an engine, hook it into other existing systems, and we run these processes. So the research that came from Petrinets heavily influenced the industrial modeling languages and also the executions engines as they work. We even can annotate data, who's supposed to work on certain tasks. But there's one inherent assumption in all these things, in these models, in these engines. One process instance is executed in isolation. Right? We have the case, right? So process mining, we extract data regarding a single case identifier, and that's what we do. And this is what we exploit in process mining. I call this single-dimensional process thinking. And you think, okay, what other dimensions are there? To start with, at the very, very basic way, you can think of behavioral dimensions in two directions. One is how many objects you're looking at, and one is how many dynamics you're analyzing. BPMN describes very well how one case, one object is handled over time. One insurance claim, right? That's what it does really, really well. But there's so many things out there that this doesn't capture. Time is not modeled. We don't model workload or how multiple actors behave, things which are analyzed in queuing theory, operations research, organization research, routine dynamics. You can't put it in there. It's outside the scope of BPMN. Obviously, multiple entities, multiple objects studied in social network information systems and in databases, right? Relations between objects. It's not in there. So, but all these things matter for processes. I mean, we know this, right? Everything here out there matters how a process runs. So that renders our small BPMN models like a point mass in a vacuum. In physics, right? When we model physical systems, what you learn in high school, you have a point mass in a vacuum and then have simple physical equations. It's good to start, but it doesn't reflect reality. If you want to solve real problems, you have to look at these other phenomena. So what I want to cover in this tutorial is to reach out into these other areas by simply looking at what happens if we add multiple objects. Well, some of you probably know this already, object-centric process mining, artifact-centric process modeling, but also what happens if you analyze multiple flows, multiple dynamics, and then, of course, what happens if you combine them together. So the goal of today is, at the basic, that you get an idea of how to think in more than one behavioral dimension, beyond BPMN. Just that you have an idea how to do this in a structured way, that there are some concepts that help you to do that. I want to show you also that actually all the processes that we're looking at are multidimensional. I mean, I've shown you this picture, but I want to show you more to convince you that it's really true, and that even the event logs that we have, the public event logs, even the ones from 2012 that Bardewijn talked about, it's so old, they show it. It's in there. You just have to look for it. I want to show you how. And then finally, that there are some simple concepts, also some basic tools that have been developed over the last years that you can apply and explore this data. This doesn't solve any problems yet in industry, but what I hope is that it leverages your thinking into approaching these problems in a different way, and yeah, to some extent, help me expand further into this space. So that at the end, next year, your papers that you can no longer assume that processes are executed in isolation, but that you actually can include something of that outside in your work as well. Well, no less than that. So before we begin, I have to thank a couple of people who have been really supportive and transformative in reaching that thinking. The people who I've been discussing with on research proposals, PhD students, Vadim sitting here was very influential. But most importantly, I'm mentioning one company, Van der Lande Industries. They're building material handling systems, baggage handling systems, which are processes, but they're very, very different, and their problems are very, very different. And studying these helped me a lot in kind of changing perspective on many things. Okay, so that was the introduction, and this was the time to get everybody else into the room. So welcome, everybody. So now we start.